Good morning, one and all. Myself, Nyamatulla Patel, Assistant Professor, Department of Computer Science and Engineering, Sugar Institute of Technology. Today we are going to start the module 5, clustering analysis of data mining and data warehousing. So in this module, I am going to cover what is clustering, overview of clustering or introduction to clustering and types of clustering. Then K-means algorithm, agglomerative hierarchical clustering, DBSCAN, cluster evaluation, density based clustering, graph based clustering, scalable clustering algorithms. So let us start with overview. Clustering. What is clustering or cluster analysis? Finding group of objects that the objects in a group will be similar or related. So here in cluster analysis, I need to find out a group of objects which are similar. When I have hundreds or thousands of the objects available in a group, so I need to separate those groups into the cluster, and each cluster will have only those objects which are similar or related to one another. And the cluster in different objects are unrelated or different from each other, different from one and another. So cluster in one objects will be unrelated or they will be different from other objects. So greater the similarity within the group. So what we need to do? So our cluster, I need to form a cluster of the objects which are similar to one another. So that is the similarity, greater the similarity within the group and greater the difference between the group, better or more distinct clustering. So what our intention is, so we need to cluster or we need to separate or we need to form a group of objects which are similar to one another, and at the same time there should be separate from other groups. Then only better clustering can be achieved or more distinct cluster can be achieved. Clustering analysis divides data into two groups or clusters that are meaningful, useful, or both. Cluster analysis, what it does, it divides data into groups or clusters that are meaningful, useful, or both. In the context of understanding data, clusters, so whenever a huge amount of data is there and if you want to analyze that data, okay, so clusters are the potential classes or clustering analysis is the best method using which you can understand different data clusters or data that belongs to the same group you can separate. So now what is clustering analysis? Clustering analysis is study of techniques for automatically finding classes. Clustering analysis is nothing but it is the study of techniques for automatically finding different classes. So clustering application, so where I can apply. So what is the advantage in grouping the objects that are similar to one another into one cluster? So what is the advantage? What is the advantage in making clusters? What I get from that? So there are a huge number of applications for this, because of which we need to go for clustering. So one is biology. Biologists have applied clustering analysis to analyze the large amount of genetic information that are available now. So genetic information, whatever available today. So this clustering has been used to find the group of genes that have similar functions. Okay, so the genes that have similar functions that can be grouped into a cluster. Okay, so information retrieval. So today the World Wide Web contains millions of the or billions of the web pages. So whenever you put a query, the search engine will give thousands of returns, thousands of results to you. So clustering can be used to group these search results into a smaller number of clusters, each of which captures a particular aspect of the query. So whenever you put a query into a Google search today or Google search engine, so it will display the pages which are only related to the query what you have posted. It will not post any unrelated pages. Then climate. Understanding the Earth's climate requires finding patterns in the atmosphere and the ocean. To that end, clustering analysis has been applied to find patterns in the atmospheric pressure of polar regions and or of the oceans that have a significant impact on land climate. Psychology and illness. An illness or a condition frequently has a number of variations, and clustering analysis can be used to identify these different subcategories. Business collects large amount of information on current and potential customers. Clustering can be used to segment customers into a smaller number of groups for additional analysis and marketing activities. Okay, next coming to the types of clustering. So there are two types of clustering. One is partitional clustering and one more is hierarchical clustering. Clustering is nothing but clustering is a set of clusters. An important distinction between hierarchical and partitional sets of clusters. So now what is partitional clustering? A division data objects into non-overlapping subsets or clusters that each data objects is exactly one subset. So partitional, so here we are dividing the objects into non-overlapping subsets. So each cluster will be independent. So each cluster is not related to any other cluster any other cluster. Then what is hierarchical clustering? A set of nested clusters organized as hierarchical tree. So now clusters are arranged in the form of an hierarchical tree. So types of clusters. So one is well separated clusters, center based clusters, contiguous clusters, density based clusters, property or conceptual clusters. So now what is well separated cluster? A cluster is a set of points such that any point in the cluster is closer or similar to every other points in the cluster than to any point in the other cluster. So here all the points in this cluster are similar to one another, so they are grouped into one cluster. So all the points in this are similar to one another and different from this cluster. So the objects and or points in this cluster are similar to one another and they are different from one another. For example, these are, you can see these are horizontally aligned, these are vertically aligned, or their different characteristics also, the variations. So well separated cluster, each point is closer to all the points in its own cluster than to any other points in the other cluster. So then center based cluster, or it is also called as prototype based cluster. A cluster is a set of objects such that an object in a cluster is closer or more similar to the center of a cluster. So now here we find a center of the cluster. Okay, so then objects in this cluster is closer to the center of the cluster than to the center of other cluster. So we are not, so center of the other cluster we are not interested. So the objects in the cluster should be closer to the center of this cluster. The center of the cluster is often a centroid, the average of all points in the cluster, or a median, most representative point of the cluster. So center based cluster, each point is closer to the center of its cluster than to the center of other cluster. Then contiguous cluster or graph based cluster. A cluster is a set of points such that point in a cluster is closer or similar to one or more other points in the cluster than to any other points in the cluster. So here 2 points are separately. So here are graph based clusters. So where these two clusters are not closer to one another. A cluster points such that points in a cluster is closer to one another or more points in that. So other clusters, they are unrelated. So contiguous cluster, each point is closer to at least one point in the cluster. So now what is the reason? each point is closer to at least one point in the cluster than to any point in the another cluster. Then coming to the density based cluster. A cluster is a dense region of the points. So what is a cluster? Cluster, another definition of the cluster. What is a cluster? Cluster is a dense region of points which is separated by low density regions from other high regions of the density. So you can find so many objects or so many points are here. So now clusters, what we do? So this is one cluster, so this is another cluster, this is another cluster. So here density of the points, whatever you observe here and here, that is high. So high density points are separated into form of a cluster. So a cluster is a dense region of the points which is separated by low density regions. So this is low density regions and these are high density regions. So when we use, this is used when the clusters are irregular or intertwined and when noise and outliers are present. So this is a cluster. These all points are called as outliers. These all points are called as outliers. Okay, so when there is a presence of noise also near the cluster, at that time we use density based cluster. Shade property or conceptual cluster finds cluster that shares some common property or represents a particular concept. So here you can see this is the region where this cluster and this cluster share some similar properties in this region and somewhere into these regions. So points in the cluster, what they do, they share some common property or represent a particular concepts. Points in the cluster share some general property that derive from entire set of the points. Or points in the intersection of the circle belong to the both. So here these points belong to both the clusters and here also this region also belongs to both the clusters. So next is k-means clustering, partitional cluster. So k-means clustering. So next, one of the most popular clustering algorithm is k-means clustering. So here clustering algorithm is a partitional clustering approach. It is a partitional clustering approach. Each cluster is associated with a centroid or the center point. So each cluster will have a centroid or a center point. Each point is assigned to the cluster with the closest of the centroid. So whenever we are finding a cluster, so all the points are closer, or the points are selected such that they are closer to the centroid. So number of cluster, k must be specified. So whenever we are applying k means clustering, so number of how many clusters I need to find, that k means that number of clusters k must be specified clearly. So what we are doing here, so first select k points as the initial centroids. So select some k points as the initial centroids, repeat this, form k clusters by assigning all the points to the closest of the centroid. So take a cluster and select all the points such that all they are nearer to the centroid. Recompute the centroid of each cluster until the centroid does not change. So here initial centroids are often chosen randomly. So initially, so I need to find out the centroid. For example, this cluster you take, I need to find out the centroid of this cluster. So initially what we do, initially we will select the centroids. The centroids are randomly selected. Then clusters produced vary from one run to the another. So now this, in only one run we are not able to form the complete k number of clusters. So consider for example k equal to 5 means I need to find 5 clusters. So in a one run I cannot find all the clusters. So now when we run multiple number of iterations, clusters produced vary from one run to the another. The centroid is typically the mean point in the cluster. Centroid, the centroid, what is the centroid or the center of the cluster is typically the mean of the points in the cluster. So the value, how you select the center point of the cluster, it is the mean of all the points in the cluster. Then closeness, what is closeness? Closeness is measured by Euclidean distance. So how you find the whether a particular object or a particular point is near to the centroid or no, or the 2 points in the cluster are they are similar or no, how we find out? Based on there is a distance called as Euclidean distance. So if the Euclidean distance between the 2 points is very less, then we can find out and we can say the 2 points are belong to the same cluster. Or cosine similarity is another function which can be used to find out the closeness among the different points, or correlation is another method. K-means will converge for common similarity measure mentioned above. So K-means will use either any one of the either it will use Euclidean distance, or it will use cosine similarity, or it is correlation. Most of the convergence happens in the first little iteration. So most of the so in first iteration only we are going to find out all the clusters or all the points that belong to the same cluster. Often the stopping condition is changed until relatively few points change clusters. So in one iteration we are not able to find how many clusters we want. If I want 10 clusters in one iteration only, I cannot find all the 10 clusters. So this I need to run for some multiple number of iterations until very few points change the clusters. What is the complexity of the K-means algorithm? It is O into K into I into D, O of. So what is N? N is the number of points, K is the number of clusters that I want to find, I is the number of iterations, so for how many number of times the algorithm you are going to run, and D is equal to number of attributes. So now how we are going to evaluate K-means cluster algorithm? So whether the K-means algorithm is performing well or no. So most common measure is sum of squared error, SSE. So for each point the error is the distance to the nearest cluster. So now what I need to find out is the distance between the 2 points in a cluster should be as minimum as possible. If it is more, and even you put, if the distance between the 2 points or Euclidean distance between the 2 points is very large, but you have put into the same cluster, then that will result into the error. So error is the distance to the nearest cluster. To get sum squared error, we use this formula. We square these errors and sum them. So SSE is equal to summation I equal to 1 to K for all x belongs to C of I summation distance square. This distance is Euclidean distance m of I comma x. So where x is data point in the cluster. Okay, so what x is a data point in the cluster, C of I, and m of I is the representative point for cluster C of I, can show that mi correspond to the center or mean of the cluster. So now, given two clusters, we choose the one with the smallest error. So when you have two clusters available, so in which when you have two clusters available, a particular point, in which cluster I need to add it? So that depends on, how it depends on? It depends on the smallest error and the less Euclidean distance. One easy way to reduce SSE is the sum squared error, is to increase K. So if I want to reduce the errors in forming the cluster, what we used to do is we need to increase K, means we need to increase the number of clusters. A good clustering with smaller K can have a lower SSE than a poor clustering with higher K. So usually a good clustering, what is a good clustering? A good clustering with smaller K can have lower sum squared error than a poor clustering with higher K value. Problem with selecting initial points. If there are K real clusters, then the chance of selecting one centroid from each cluster is small. Change is relatively small when K is large. Okay, so if clusters are the same size n, then P is equal to probability. What is the probability? P is equal to number of ways to select one centroid for each cluster. For every cluster we need to find a centroid. Then I need to take the objects, match with the centroid point. If they match with the centroid point with the least distance, then add it to that cluster. Okay, number of ways to select one centroid from cluster divided by number of ways to select K centroid, that is K factorial n raised to K, that is K into n raised to K, that is K factorial by K raised to K. For example, if K equal to 10, then what is the probability? It is 0.0036. Sometimes the initial centroids will adjust themselves in right way and sometimes they don't. K-means algorithm, what are some additional issues in this? Handling empty clusters. So basic k-means algorithm can yield empty clusters. Some of the times what happens, so whenever you are applying k-means clustering algorithm, k-means algorithm may yield some empty clusters. So if there are some empty clusters have been formed, so what you have to do? Choose the point that contributes most to SSE. Now choose, so whenever there are some empty sets or empty clusters, then what you have to do? Choose a point that contributes most to the SSE. Choose a point from the cluster with the highest SSE. If there are several empty clusters, the above can be repeated. So now what I am doing? So now I will be removing the points that contributing to the error, and also I am choosing a point from the cluster with highest SSE. So if the errors are more, then what we have to do? So these points with the highest error can be eliminated, and that will be helpful to reduce the cluster. Okay, so now updating centers incrementally. So now center point, so you take a center point and then assign the points to that cluster according to the Euclidean distance. In the basic k-means algorithm, centroids are updated after all the points are assigned to a centroid. Now in the basic k-means algorithm, centroids are updated after all the points are assigned to a centroid. So first initially we will take centroid, and then we are keep on doing these iterations until we form a centroid such that all the points are belong to the same group, and this will be repeated. So an alternative is to update the centroid after each assignment, that is incremental approach. So what we are going to do is each assignment updates 0 or 2 centroids. So but this is more expensive, and it also introduces an order dependency, and but advantage is never get an empty cluster, can use weights to change the impact. So before we apply k-means clustering algorithm, so what pre-processing and post-processing we can do? Pre-processing, normalize the data, eliminate outliers. The points that are far away from a particular cluster or they are having the highest Euclidean distance, remove those points. Then after post-processing, eliminate small cluster that may represent outliers. If the point, there are some points that are not in the cluster, they are there away from the cluster, remove those points. Split loose cluster, that is cluster with relatively high SSE. So eliminate the cluster which is having the highest sum squared error. Merge cluster that are close and that have relatively low SSE. If there are two clusters and both these clusters are having low sum squared error, then merge those two clusters. Can use these steps during the clustering process. Now, strength and weaknesses of the k-means limitations. K-means is simple and can be used for wide variety of data types. It is also quite efficient even though multiple runs are often performed. So k-means is efficient algorithm even though multiple iterations are required, multiple number of times I need to run the algorithm. K-means is not suitable for all the type of data. What? K-means algorithm is not. K-means clustering is not suitable for all the types of data. K-means has problem when clusters are differing. When we have clusters of different size or clusters of different densities, or if the clusters are having different shapes, then K-means has problems when clustering. K-means has problem when the data contains outliers also. So if there are some points which contain some outlier point, then also the K-means algorithm has some problems. Then coming to the another point, bisecting k-means. Bisecting k-means algorithm is a straightforward extension of the k-means algorithm. Bisecting is an updated version of the k-means algorithm that is updated, that is based on a simple idea. To obtain k clusters, split the set of points into two clusters. So now what we are doing? To obtain k clusters, split set of all points into two clusters. Initially what you do, you take all the points divided into two clusters. Select one of these clusters to split and so on until k clusters have been produced. Then go on bisecting. Bisecting is nothing but cutting down. So when you have a huge number of points available, cut them into two clusters, and this process should continue until you have required number of clusters have been produced. So now what is algorithm for this? Bisecting k-means algorithm. Initialize the list of clusters to contain the cluster consisting of all the points. Remove a cluster from the list of clusters. Okay, so how? If the clusters are having high sum squared error, remove those clusters. Perform several trial bisection of the chosen cluster. So every time you need to do iterations and you need to perform several trials of cutting down or bisecting of the clusters. For I equal to 1 to the number of trials I do. So number of trials. So I equal to, it may vary. I may have 1 trial, 2 trials, 3 trials, 5 trials or 10 trials. After 10 trials I may get an equal number of a proper number of k clusters. Bisect the selected cluster using k-means. Then select 2 clusters from each bisection with the lowest SSC. So from each bisection take the clusters with the lowest sum squared error. Add these 2 clusters to the list of the clusters until the list of the cluster contains clusters. There are a number of different ways to choose which cluster to split. We can choose the largest cluster at each step. Now what? There are a number of different ways to choose which cluster I need to split now. So which cluster I need to split? We can choose the largest cluster at each step. So every time whenever you want to split a cluster, now which cluster I need to split? You have to select a cluster that is having the largest in size, largest cluster at each step. Choose the one with the largest sum squared error or use the criteria. There are different ways what you can do. You can choose the largest cluster or choose the one with the largest sum squared error or use a criteria based on both size and SSC. Different choices result in different types of the clusters. So that is for today, for this session. In the next section, in the next video lecture, I will be taking an example. Using this example, we will explain how k-means clustering algorithms work. So for this video lecture, this is sufficient. Thank you one and all.